Here is an application of algebra, a word problem which can be solved either using one variable or two variables. So when we use one variable to solve any word problem, it is a linear equation, and the other one, when we use two variables, it is an example of using or application of simultaneous equations or a system of equations in two variables. Let us start solving it using one variable first. So the question is, a father is currently 3 times as old as his son. In 10 years, the father will be only twice as old as his son. So we are talking about ages of father and son, their relationships, how they are related, and how old are they currently. So both their ages are unknown, and we are to find their current ages, present ages, and we have to use only one variable. So in such questions, it is always suggested that the smaller value be assigned a variable. So out of the ages of father and son, son's age is smaller than the age of the father. So let us say son's age be x years. This is, we are talking about the current age, present age. So therefore, father's age, according to the given question, it says it is 3 times as old as his son. So if his son is x years, his father's current age is going to be 3 times as his son's age. So 3 times his son's age is 3 into x, which is 3x years. This is again the current ages. Next, it says in 10 years. So when it says we are talking about age in 10 years. So meaning after 10 years. So in a span of 10 years, 10 years will be added both to both the ages of son as well as father. So after 10 years, father's age is going to be 3x plus 10 years, and the son's age is going to be x plus 10 years. And the relationship is, in 10 years, the father will be twice as old as his son. So let us translate this statement into mathematical formula. So father's age is 2 times or twice the son's age. So we got an equation. We need to solve this equation. So I open up the brackets and I get 2 times of x plus 2 times 10, which is 20. I have variables to both sides of the equation. I'm collecting like terms. So 2x gets transposed to that side and I get 3x minus 2x. Here I have 20 left, and at the same time I am bringing this 10 to this side of the equation. So positive 10 changes to negative 10. 3x minus 2x gives me x is equal to 10. So which is, as we know, that son's age is x years and the x is 10. So which is your son's age? Son's present age. So next we are to find the father's age. So father's age is, current age is 3 times of x. 3 times the value of x here is 10. I substitute in place of x, I substitute 10 and I get 30 years. So I have the son's current age 10 years and father's current age 30 years. This was using one variable. Let us try using two variables to solve the same question. Okay, so I have son's age and I have father's age, and we are talking about the present ages. So present ages of son's age is x and the father's age is y. The current age, present ages. Then we talk about their ages in 10 years. So age after 10 years, we will add 10 years to both their ages. So son's age is going to be x plus 10 and the father's age is also going to be y plus 10. So after a span of 10 years, 10 years are added to their ages. The condition now is, so currently father is 3 times as old as his son. How do we represent this by means of an equation? So the first equation is uh, father is father is y. So father is 3 times old as his son. Father is 3 times as old as his son. This is the first equation, and the second equation says in 10 years the father will be. So I start with the father, and the father here is y plus 10. So in 10 years the father will be twice as old as his son. So this is the son's age. So I write it here, x plus 10. So I have two separate equations, one for the current ages and the other for their age after 10 years. I simplify the second equation, and along with that, the easiest method here to solve this equation is by substitution. So in place of x, y, I can always substitute 3x because my y is equal to 3x. So in place of y, I can always substitute 3x over here, and I get 3x plus 10 is equal to, I open up the brackets and I get 2 times x plus 2 times 10, which is 20. I again collect the like terms to one side. I bring this 2x to this side. It becomes negative 3x minus 2x is equal to 20 minus 10. X is equal to 10 years. So if you check, if you compare my x here as well as here, they are the same. So this is the son's age, and the father's age is going to be 3 times the son's age. So again the father's age was y, which is 3 times x. I substitute the value of x. In place of x I substitute 10, and I get 3 times 10, which is 30 years. This is the father's age. So this is my answer for son's age as well as father's age, the current ages.